Welcome to our third tutorial. Today we'll be investigating arrays and in the process creating a program that manipulates an audio file. We will be adding an echo to that audio file. To start with, we're going to need to head to our FTP program. I'm using CyberDuck here. You should navigate to My Directory, Home, WPS0, and DUI, and you'll be able to find two files there, AudioArray and Tony.aif. I'm going to create a new directory on the server. I'm going to call it tutorial. I'm going to move those two files into that directory. Tutorial, Tony. If we go to tutorial, we should see that those two files are now in that directory. Alright, now I'm going to open up my shell program terminal. I'm in my root directory, or my home directory, excuse me. So I'm going to change my directory to the tutorial directory. And the contents of my tutorial directory contain the audio file, Tony.aif, and this RB file. We're going to be using that Ruby file. It contains a class that will make the audio manipulation simpler and more array-like. So I'm going to use VI as my editor. I'm going to create a file echo.rb. To start with, I'm going to have to include that RB file, audio array, on a Unix-based operating system. First, you must require Ruby gems to let it know that we're going to need gems, and then we're going to include our file, audioarray.rb. Or excuse me, not include, we're going to require our file, audioarray.rb. Require basically takes whatever code is in audioarray.rb and adds it to your project. So the code that we've added is a class. Remember, other classes we know are string or fixnum that we instantiate, or the time class, or recently we learned about the array class that we're looking at today. Our audioarray.rb adds an audio array class. Audio array, when you instantiate it with the new method, takes a file name and it turns that audio file into an array so you can manipulate it. So I'm going to pass audio array class in the new method, or in the new message, a string containing the name of the audio file which we put in my folder. And then I'm going to store in a variable audio array the object that is then created that contains this array-like structure. Now, audio array basically acts like an array. So if I put the audio array 0th index of audio array, if I save my program and quit out, and I run this program, ruby echo.rb, I get back a number. Now what does that number represent? Inside of the audio file, that number is a value that represents the audio sample at that location in the array. Each moment in time there is an audio sample that is stored at a certain sample rate. And this is the very first audio sample in the file. Notice it's a very small number. If we investigate further into the audio sample, this audio sample in particular has a sample rate of 44,100 samples each second. So every second there were 44,100 of those numbers recorded that represented the audio level at that second. And that's not the volume necessarily. It is a different type of number that is stored. But all those samples together, depending on the rate that they're changing and the level that they're at, end up in the volume and the sound that is produced. If we look at the 44,100th sample, we'll see the audio a second later. See that it's significantly increased in volume, that's for sure, because the number's higher. But that means probably there's also been some changes in the pitch. Okay, so let's see what we can do with this audio array. When we're working with an audio array, this audio array has a lot of samples in it. And actually we can investigate the total samples of this array and see that it has 407,000 samples. So if we take our numbers from before, let's hop into IRB real quick. 407,925 samples. Excuse me. 407,925 samples divided by 44,100 samples per second gives us about 9 seconds, or exactly 9 seconds of audio. 9.25 seconds of audio. So let's quit out of IRB, hop back into our echo program. And since we have 407,000 samples, we're probably not going to be selecting individual samples and editing them, as editing individual samples isn't going to make much difference to our program. What we're going to do in this program is we're going to create a filter that when we run on an audio file will add an echo to that audio file. So to do that, we're going to have to iterate through the entire audio file. And to iterate through it, we're going to have to treat it like an array and proceed through it one index at a time, changing that index. Now to add an echo, we're going to have to look back in time through our frames to a previous sample some time ago and add it to our sample now. So we're going to need some sort of delay for our echo. So I am going to store my delay. Let's make a 0.2 second echo to start with. We could make a 1 second echo if we wanted the echo to be a second ago, or a 2 second if we wanted to be 2 seconds ago. So in order to calculate how many samples our echo has to be, we're going to have to do a little conversion here, because this is 0.2 seconds of echo. But 0.2 seconds isn't 0.2 samples, it's thousands and thousands of samples. So to figure that out, we're going to have to take the number of samples in 1 second and multiply that by our delay. And we're doing our samples per second times our seconds of delay, and that will give us our number of samples of delay. And we're going to toss that into an integer. Since our delay is smaller than 1, this could be a float number, and samples are always integers, the number of samples. Samples are a discrete quantity. So we'll store that in a variable echo samples. So now we have our delay variable, and we've created a variable from it, echo samples, which represents how many samples are in an echo. So let's check out that variable real quick. Hop out and run our program here. It looks like I've mistyped sample rate as samples rate. I knew that was the case because it said undefined method samples rate, first of all, and I knew it was called sample rate, and when I went to look at line 7, I saw that in fact I had typed that. There we go. So 8,820 samples is going to be how far back 0.2 seconds is in our audio. So now what we need to do is we need to go through every frame of the audio and go back 0.2 seconds, find the echo, and add it to the current frame. So to go through every frame of the audio, what I'm going to do is I'm going to take my array and I'm going to take the total number of samples and I'm going to run the times iterator on it. Remember, what times does is it loops a number of times of the number given to you. So for instance, if I happen to IRB, 5.times will loop through the following code and puts high 5 times. Times also passes a block argument that contains the current index of the number of times it's been through so far. So if I puts that in my block, I'll see 0, 1, 2, 3, 4, because during the first time it's run it, it's been through 0 so far. During the second time it's run it, it's been through 1 already. This is the second time, and so on and so forth. So we're going to use times to iterate through every sample. And the index that times is providing to us, we can use as the current index in our audio array. And if we just take our audio array here and if we take our audio array here and treat it like an array using the square brackets operator to access the sample index, it's going to go through every index from 0 to total samples minus 1, and it's going to find the value at that index and puts it to the screen. So I'm going to save my program and run it. Here we're viewing the entire program, or excuse me, the entire audio file. So let me hop back. We don't want to view the audio file though, we want to change the audio file. So first of all, let's take the current audio sample at the sample index and save it into a variable current sample, just so we can better understand what we have. And then remember, what we're looking to do is we're looking to go back in time to some time ago, and that's going to be where our echo comes from. So we're going to generate an echo sample. The way we're going to do that is we're going to access our audio array using the same square bracket operator, but instead of finding the sample index, we're going to find the sample index minus the number of echo samples. And that's going to give back us, it's going to give us back the sample that was echo samples ago. Once we have both of those, we're going to be able to proceed. Let's make sure that this works first. So let's put our echo sample to the screen so we can view all of our echoes. Ooh, we've got an error immediately. Line 28. So I'm going to hop into line 28 and I'm going to look for an undefined method square brackets. It says that square brackets is being called on class nil, or for an object with value nil. So definitely not line 28. Looks like actually line 28 of the audio array, which is our helper class, helper file. It's line 11 of our echo. Oftentimes the error is thrown by a class that's helping you out, and so the number's not particularly descriptive, but the second number is in the class that called you if you go down through the stack trace. So there's line 9, here's line 11. So something's wrong with this. Well, I can kind of see what it is, actually. The best way to see this probably is to put sample index minus echo samples out to my standard out here. Oh, did not comment out the offending line. Sorry. There we go. Did you see that? It was pretty quick. Let's look again, see if I can stop it. Scroll up here. Right there. Negatives. Negatives. Basically, what's occurring is at the beginning, sample index is 0, but echo samples is still some number back. And the audio array doesn't know how to treat a negative index because that's suggesting audio before the song existed. So we need to prevent that from happening. Basically, you don't want to start echoing until you've reached echo samples in sample index. We're going to use a conditional to do that. We're going to say if our sample index is greater than or equal to our echo samples. So basically, once sample index has progressed 0, 1, 2, 3, 4, 5, 6, 7, all the way to echo samples, then we will start echoing. But don't echo until then because there's nothing to echo. That's going backwards in the audio. Now, our VI editor here appears to be going on to the next line. Let me fix that. I'm going to increase my window size here. Okay. So now that we have this conditional block here, we should be safe to iterate through the whole thing. Let's test to make sure. So I'm going to quit out and run my program. No errors, ran right through. Notice it didn't produce any output because we do not have any put statements right now. So now that we have our current sample and our echo sample, we need to change the audio array. So I'm going to use another common array operator here, square bracket equals. Inside the square bracket, you put the sample the index of the array you're interested in editing, and I'm interested in changing sample index. And then to the right of the equals sign, you put the value you want to assign there. Now, if I put current sample here, then I'm just going to change the array from what it is back into what it is. It's not going to change at all. If I put echo sample here, the array is going to be quiet until the echo starts, and then it's going to sound normal. What I want to do is I want to add the current sample and the echo sample together. So I'm going to do current sample plus echo sample. But I probably don't want them to be equal. I probably want the echo sample to be a little quieter. I'm going to make this a little bigger. I probably want the echo sample to be a little quieter because your echo, we want it to get quieter. So I'm going to make the echo sample half as loud by multiplying it by 0.5. And then since now we have, instead of audio times 1, we have audio times 1.5, I'm going to divide the audio by 1.5 to normalize it back to the volume it was before, so we don't get any spikes in the audio that are loud and crackly. Okay, so what we've done is we are iterating through the array by using the times iterator to go through the total samples one at a time. We're using the conditional expression if to make sure that enough samples have passed by already before we start echoing. Then we're extracting the current sample and a sample some time ago echo samples. And we're adding them together, normalizing them, and then storing them back in the audio array. The final thing we have to do is we need to take the audio array and write it back to another file. Because right now we've just been editing it internally, and as soon as the program closes, Tony.aif goes back to what it was before. So we're going to need to call write on our audio array and give it a file name. I'm going to call that file output.aif. I'm going to save it. Okay, so I'm going to quit out and run this. Appears to have run without error. And we now have a file, output.aif. Let's hop over to CyberDuck now. Refresh my FTP. And I'll see output.aif is there. I'm going to bring it to the desktop on my local machine. And I'm going to put some headphones on here. You should do the same. And listen. And I have a echoed output.aif of the original audio file. This concludes our tutorial.